Hi friends, today in this class we will cover the Terraform architecture. The last class we covered Terraform, what is Terraform, how it works. So the Terraform basic we covered in the last class. Today we will cover the Terraform architecture. Terraform architecture mainly consists of three component. The first component is Terraform's core, and then it is provider, and then it's a state file. Terraform core, providers, state file. These three are the core component of Terraform. If you look at this Terraform architecture, DevOps engineers will write, they will define everything in the configuration files or Terraform files, which has the .tf extension. And then when they run that Terraform init, Terraform plan, Terraform apply, these Terraform commands, the Terraform core will initialize the operation, plan it, and then apply the whatever is defined in the configuration files. Terraform will use providers, provisioners. These are all plugins. There are n number of plugins available in Terraform. Terraform will use plugins, provisioners, state file to make decision, to interact with the cloud, to deploy the resources in the cloud. Let us cover the first component, Terraform core. Terraform core is a very important component. It is exposed using Terraform CLI. We will run the command terraform init, terraform plan, terraform apply. We will run this command in CLI only. Terraform keyword specify terraform binary file, exe file. Actually, it is a CLI tool to execute the whatever we define in the configuration files. It is a central component of Terraform. When we download Terraform for Windows or Mac or Linux, we will download the file, extract the file. There we will see the Terraform binary file, that is exe file. That is considered as the Terraform core. It is written in Go programming language. It is exe file, it is a binary file. It provides a command line interface, which is the primary way user interact with the Terraform. Whether it is a Mac OS, Windows, Linux, whatever it is, we interact with the Terraform through the command line only. By opening PowerShell, command prompt, Terraform init, Terraform plan, Terraform apply. These are all command line only. We will see provide this command in the command line or PowerShell or VS Code tools. So the core function of Terraform core is responsible for reading and processing the Terraform configuration files like which ends with .tf. .tf files are configuration files or Terraform files. This Terraform core will build the dependency graph of resources. When you create a project, when you create configuration files, when you create .tf files, define all your resources. So Terraform will create the dependency graph. It will automatically detect in which order that resource will be created, modified, or deployed. So this Terraform core will compare the desired configuration with the current state. Whatever we define in the .tf file, that is a desired configuration. It will be compared with the current state. For example, if we are going to deploy 5 VMs in Azure cloud and write the configuration files, when we run the Terraform commands init plan apply, it will Terraform core will check the desired configuration in the .tf file and will check with the current state of the infrastructures. Then it will generate the execution plan. It will determine which resource need to be created, modified, or destroyed. So these are all core function of Terraform core. Terraform core communicate with the providers to make the required infrastructure changes. It will read and update the Terraform state. So Terraform core will responsible for all the major core activities. Reading and processing Terraform configuration files, build the dependency graph, compare the desired configuration with the current state, generate the execution plan, decide which resource to be created, modified, ignored, or deleted, communicate with the providers, and then it will read and update the Terraform state file also. When we run the Terraform plan command, the Terraform core will analyze the configuration and the state and determine what changes are required. So Terraform core will work with the appropriate providers to execute those commands. When we run the Terraform apply, Terraform work with the providers. If it is Azure, if you are deploying Azure resources, it will load the Azure provider and connect with the Azure provider to deploy the resources in the Azure cloud. The second core component is providers. If you look at this diagram, this is Terraform core. These are the providers. So Terraform core, and then in the configuration file we will define the providers. Terraform providers are plugins that allow Terraform to communicate with the external platform and services. How the Terraform deploy the cloud resources, how the Terraform create, modify, destroy the resources in the Azure cloud, in the AWS cloud, in the GCP cloud. So Terraform will communicate with the providers. Provider will perform the action on behalf of Terraform. Providers act as a bridge between Terraform and the API of the cloud providers. So AWS provider will manage all the AWS resources. Azure provider will manage all the Microsoft Azure resources. Google Cloud provider will manage the Google Cloud resources. Kubernetes provider will manage the Kubernetes resources. DNS provider will manage the DNS records, and database provider will manage the appropriate database in the cloud. So providers define the resource and data source that the Terraform can work with and translate the Terraform operation into API request understood by the target platform. So the provider, it will define resources, it will define the data source, and Terraform will work with the provider. Provider translate the Terraform's request into API call to connect with the respective Azure AWS Google Cloud Platform. So here Azure RM is the Azure provider. It understands the Azure RM resource group resource and communicate with the Azure API to create and modify the resource group. So Terraform core is the initial component. It will read the configuration file, understand it. It will connect with the provider. Provider will check and it will make the API calls to the respective cloud platform to deploy it. See, the basic interaction is we create configuration file, Terraform configuration file in .tf files. Terraform core will read the .tf files and it will connect with the provider. Provider will make API call to specific cloud providers to deploy or update or modify the resources. So the workflow is we create the .tf files, Terraform files, configuration files, and we will run that command Terraform init, Terraform plan, Terraform apply. During the command, when we run the command, the Terraform core will read the .tf file. The .tf file contain the desired state, and then the Terraform core will read the state file, because that state file contains the current cloud infrastructure details. Then the Terraform communicate the provider. The provider, in this case Azure provider, will query the actual infrastructure through the cloud API. For the Azure provider communicate with the Azure API to obtain the current information about the resources. So we write the Terraform files .tf files and run the command Terraform init plan and deploy. The Terraform core will read that .tf file and it will check the state file. It will check the desired state and then current state, and then it will call the specific provider. The provider will make the API call to the cloud, specific cloud, and get the latest infrastructure information. Then the Terraform core will design what needs to be done, whether we need to create, update, destroy, or ignore. Then the Terraform core will coordinate with the provider. Azure provider will understand all this activity. What are Azure resource groups? Which Azure API to call? What parameters Azure expect? How to authenticate with Azure? How to read, update, delete Azure resources? And that provider translate that Terraform core request into API call, into API request. The provider communicate using API, Azure API, then Azure receive the request through Azure API calls and create the resources and report it back to Terraform. Terraform it will update this state file. So provider is a core component. Without providers, nothing will happen. The third component is state file. Terraform architecture consists of three core components: Terraform core, providers, and state file. The last core component is state file. Terraform state file is the critical component of Terraform by default. Terraform store the state in JSON file .tf state. The Terraform The Terraform state file is a JSON file which ends with that TF state. The state file contains information that the Terraform used to track the infrastructure to manage. So before deploying resource to the Azure cloud, Terraform will check the current status of the Azure cloud, which is already exist, which needs to be ignored, which needs to be created. So that state file helps to track the infrastructure changes, current infrastructure changes, current status. It can now include resource attribute, resource identifier, relationship, and other metadata need to manage those resources. So Terraform uses the state file to map resource defined in the Terraform configuration to the real infrastructures. So state file is very important. Without state file, Terraform does not know what is already created, what is already exists in the Azure cloud, AWS cloud, GCP cloud. Terraform record information about the corresponding AWS instance in the state file. It will record whatever available in the Azure cloud through the state file. So during the subsequent operation, Terraform uses the information to determine what already exists and what changes are required. The state file helps Terraform track manage resources, determine changes between the current configuration and the existing infrastructures, understand the resource dependencies, avoid unnecessary recreating resources, store information required for future Terraform operation. So state information is very critical. If there is no state file, Terraform operation will definitely fail because Terraform does not know what is already created, what is already exists, what needs to be newly deployed. It don't know. So we need to store the state file safely. Terraform state file can be stored locally or remotely. We can store the Terraform state file in a remote storage like Azure, Amazon S3 bucket, or Azure Blob Storage, or the Azure Cloud Platform, or other backend. Remote state is particularly useful when multiple team members or automation system work with the same Terraform infrastructures. This is important point to note. So we have to protect the state file. The state file should be treated as a sensitive information infrastructure data. So state file is consist of sensitive infrastructure data. Depending on the resource and providers being used, state can contain sensitive value or information about the infrastructures. So we must protect the state file. We must restrict the access to the state file. We must use appropriate encryption technology to protect the state file, and we can prefer a secure remote backend for the Teams environment. So we can enable state locking, maintain appropriate backups and recovery procedures, avoid storing state file in public or unsecured location. So in this video we covered Terraform architecture. In a nutshell, Terraform core read the desired configuration and the state. It communicates with the providers to reference the information about the actual infrastructures. Terraform then determine the difference between the desired state and the current state, and then create an execution plan. Once the execution plan is approved, Terraform core coordinate with the appropriate providers to perform the required changes. Finally, Terraform updates the state file with the resulting resource information. Thanks for watching. We'll connect in the next class.